Algebra 2, 2 worksheet 9.3a. I'm going to look at numbers 11 and 13 in this video, where we're asked to find the intersection of each system of equations. In other words, solve this system. So most likely it's going to be a set of a coordinate pair, an x and y coordinates. And the way number 11 is set up, it's got the x by itself. When you have that variable by itself, usually it's meant to be substitution. Now, if you wanted to, you could take the 2y and move it over, and you could do combination if you like combination. But here, because the x is by itself, what I'm going to do is I'm going to substitute this whole thing into the x value here on that second equation. So this becomes 4 times the quantity, 2y minus 3 minus 5y, everything else stays the same, equals negative 3. I'm going to distribute the 4. I get 8y minus 12 minus 5y equals negative 3. I'm going to combine like terms. I get 3y minus 12 equals negative 3. I'm going to add 12 to both sides. I get 3y equals positive 9. Divide by 3, I get y equals 3. So I know the y coordinate for my solution is now positive 3. Then I'm going to take that answer and I'm going to plug it into either one of these equations, doesn't matter which one. X is nicely set up here, or this first equation is nicely set up here. So I'm going to go x equals 2 times the y value, which is 3, minus 3. 2 times 3 is 6 minus 3. And 6 minus 3 is 3. So my solution for number 11 is the point 3, 3. Now I'm going to look at number 13. Now number 13 is set up better for combination because you have the x's and y's together on the same side. They're all lined up vertically. So what I'm going to do is I'm going to try to get rid of the x's here first, because I'm looking at negative 5 and positive 10. I want these to cancel, so they're already negative and positive. That I like those signs, but now I have to make them both make the numbers match, and I can do that by multiplying this by 2, because then it'll be negative 10 and positive 10. So this second equation stays the same, 10x minus 6y equals 4. But this first equation I'm going to multiply by positive 2. That gives me negative 10x plus 6y equals negative 4. Now when I combine, notice what happens. The x's cancel. The 6y minus 6y cancels. Negative 4, positive 4 cancels. All I'm left with is 0 equals 0 with everything gone. And since 0 does equal 0, those are the same amount. This is an infinite solution problem.